Welcome to this presentation on HPLC for practicing scientists. This is episode 3A, focusing on the 5 basic concepts of HPLC: K, alpha, N, RS, and TF. In this session we will cover the following fundamental concepts in HPLC: retention factor, K, selectivity, alpha, column efficiency, N. Now let's discuss the retention factor, denoted as K or K. K is a measure of peak retention, indicating how many times a peak is retained compared to an unretained peak, Tm. The formula for K is Tm/Tm. K depends on mobile phase solvent strength or %MPB, but it is independent of L or F. Next we'll delve into selectivity, alpha, of 2 adjacent peaks. Alpha is calculated as K2/K1, and it represents the differential retention of 2 analytes by the column. For proper peak separation, alpha must be greater than 1.0. It is essentially the ratio of retention factors of 2 peaks. Let's move on to column efficiency or plate count, N. Plate number, N, is a measure of column efficiency or separation power. A high N value is desirable for complex samples because narrower peak widths mean more peaks can be separated in the chromatogram by a high efficiency column. The theoretical definition is N equals TR/sigma, (2), and the USP definition is N equals 16 TR/WB, (2) or 5.54 TR/W1/2, (2). The goal of most HPLC separations is to achieve resolution for all key analytes. RS is a measure of the degree of separation of 2 peaks. RS equals 0 means no separation, 1 indicates partial separation, and 1.5 signifies baseline separation. For 2 components to be separated, analytes must be retained, K greater than 0, and have differential migration, alpha greater than 1.0. Narrow peak widths, large N, are also helpful. This slide illustrates the resolution, RS, of 2 closely eluding peaks, ranging from RS equals 0.6 to RS equals 2.0. Baseline separation is achieved at RS equals 1.5, while RS equals 2.0 is more ideal. Baseline resolution for all peaks is a regulatory requirement in purity assays. Now let's talk about the tailing factor, TF. Peak fronting typically indicates column overloading, while tailing suggests secondary interaction. Peak tailing of basic analytes is often caused by residual silanol activity of the bonded phase. The tailing factor, TF, is defined as W0.05/2F, according to the USP definition. In summary, we've covered 5 basic concepts in HPLC: retention factor, K, where K equals Tm/Tm, selectivity, alpha, where alpha equals K1/K2, column efficiency, N, where N equals TR/sigma, (2), resolution, RS, where RS equals TR1/TR2/WB, and tailing factor, TF, where TF equals W0.05/2F. Here are some references for further reading. Thank you for watching. Please subscribe to this YouTube channel.